On behalf of 24houranswers.com, I welcome you to today's lesson. In this video, this is example 2 of L'Hopital's rule, and we're going to have the 0 over 0 form again, just like we did in example 1, but in example 1, I did show you the alternative technique of factoring to get that same limit. However, sometimes we cannot factor, therefore L'Hopital's rule is pretty much our only way out of this particular situation. So we have this function f of x, and once we get this limit doing L'Hopital's rule, we're going to come back and in fact see that yes, that limit is going to be whatever we get. And we're going to use Desmos to show that. So back to this problem, we've looked at the definition, but now I have this new part. You may need to do L'Hopital's rule more than once. Let's try direct substitution. The limit as x approaches 0 of this function that we've called f of x over here. If we try direct substitution, e to the 0 power, well, that's going to be 1, minus 0, and then minus 1. So up top, we get a 0 in our numerator. Plug in 0 into our denominator. 0 squared is equal to 0. So notice we do have the indeterminate form of 0 over 0. L'Hopital's rule simply states the following. We can take the derivative of the top and the derivative of the bottom, and we can try plugging in 0 again. We do not use the quotient rule. We take the derivative of the top. The derivative of e to the x is e to the x. The derivative of negative x is negative 1, and the derivative of negative 1 is 0. So that's the derivative here of our numerator. The derivative of our denominator is going to be 2x. So let's try direct substitution yet again. Plugging in 0, we have e to the 0, that's 1, minus 1, all over, plugging in 0 again. 2 times 0 is 0. Well, notice we have 0 over 0 again. So you may need to do L'Hopital's rule more than once. So one more time, let's see if we can get it on this one. The limit as x approaches 0, let's take the derivative of the top again and the derivative of the bottom. The derivative of e to the x is e to the x. The derivative of negative 1 is 0, so I'm going to leave that off. And this is all over now just 2 because the derivative of 2x is 2. Trying direct substitution, we get e to the 0 power, that is 1. And then we don't have an x anymore down here, so we get 1/2. That is going to be our limit. So we have this function here. As x gets close to 0, even though the function is undefined when x is 0, we are getting close to a y value of 1/2. So here we have that same function f of x, and you do notice that f of 0 is undefined. But let's take our mouse pointer here and let's get real close to an x value of 0. And what I want you to notice here is that as we get close to an x value of 0, that y value is getting doggone close to 0.5, right? Check it out. Now, when we hit 0, we see that undefined. But over here on this side as well, if I'm coming in from the right-hand side as we get close to 0, for x, look at what the y value is getting close to. 0.5. That's a half, right? That's exactly what we got here. So hopefully you do see the power of L'Hopital's rule. We could not factor this thing. That's why we have L'Hopital's rule. You get a 0 over 0 form. You can take the derivative of the top and the derivative of the bottom, and if it don't work there, try it again. But again, this all revolves around the 0 over 0 form. There are more forms to discuss, and we will see those in future videos. And there you have it, example 2 of L'Hopital's rule. And that's it for this video. I hope it helped. Be sure to check out our YouTube channel for more videos. Links to our social media are in the description below.